Here are all of the basic differentiation rules for elementary functions. So I would take a minute, pause this video, and write down all of these. Make note cards for all of these. You could be tested on any of these. Okay? All right. So let's look at this next example, explicit differentiation. Find an equation of a tangent line to the graph of the equation at the given point. So we have our equation here. We have a point. We want to find the equation of the tangent line at this given point going through this function. So we need to take the derivative of arc tangent of u with respect to x, which we know is u prime all over 1 plus u prime. We're also going to take the derivative of arc sine of u dx, which is u prime all over the square root of 1 minus u squared. So let's do that. And you can notice here that this is going to be an implicit differentiation situation because we got x and y on the same side of the equation. So let's try taking the derivative of arctangent of u. So u prime is, we need to take the derivative of x times y, which that's going to be the product rule, all over 1 plus xy squared would be x squared y squared equals arc sine of x plus y. So this is going to be x plus y is u, so you're going to do x plus y prime. We're going to take the derivative of that all over 1 minus x plus y squared. Okay? So now, the numerator of both of these fractions here, we need to take the derivative of those. So let's do this product here. So it's going to be the first function, which is x, times the derivative of the second function, which would be 1. But here you're going to do dy dx, because we're taking the derivative with respect to x, that's a y, plus the second function times the derivative of the first function. So I did the product rule up there, all over 1 plus x squared y squared equals, okay, the derivative of x would be 1, the derivative of y is 1, but again we need to do dy dx because this would involve implicit differentiation because we're taking the derivative of y where it needs to be in terms of x. All over 1 minus x plus y squared. Okay, so now we need to simplify this. Let's see, this side, this is going to be x dy dx plus y all over 1 plus x squared y squared equals 1 plus dy dx all over the square root of 1 minus x plus y squared. Now, let's see here. Okay, next thing we need to do, we need to get dy dx by itself. So I'm going to cross multiply here. So this is going to be 1 plus x squared y squared, I'm going this way first, times 1 plus dy dx all over x dy dx plus y times the square root of 1 minus x plus y squared. Okay. Let's see here. Now I need to distribute all the way through here. So 1 times 1 is 1. 1 times dy dx is dy dx. Let's see, this is going to be x squared y squared. And this would be x squared y squared dy dx. Equals this would be x times the square root of 1 minus x plus y squared dy dx. And then this right here would be y plus square root of 1 minus x plus y squared. Okay, so next I need to get all the dy dx's on the same side. So I got a dy dx there, dy dx there, dy dx here. So what I'm going to do, I'm going to write dy dx here plus x squared y squared dy dx. And then to move that to the other side, it's going to be minus x, the square root of 1 minus x plus y squared dy dx. And then the other side is going to be y times the square root of 1 minus x plus y squared. And then I'll move over minus 1 minus x squared y squared. Next, I'm going to factor out dy dx. So I'll be left with 1 plus x squared y squared minus x times the square root of 1 minus x plus y squared equals y times 1 minus x plus y squared minus 1 minus x squared y squared. And then finally, I'm going to get dy dx equals y times the square root of 1 minus x plus y squared minus 1 minus x squared y squared divided by, then I'm going to divide it by this. So 1 plus x squared y squared minus x times the square root of 1 minus x plus y squared. Okay, so now I have dy dx, it's solved. Now I need to figure out dy dx for 0, 0. So everywhere there's a y or x, I'm going to plug in 0. So y is 0, x is 0, y is 0, squared, minus 1, minus 0 squared times 0 squared, all over 1 plus 0 squared times 0 squared, minus 0 times 1 minus 0 plus 0 squared. So it looks like the numerator is going to end up being 1, the denominator, or negative 1, the denominator is going to end up being 1. So it looks like my slope is negative 1. I got a point at 0, 0, so let's try to find the equation of the tangent line. Y is 0, m is negative 1, x is 0 plus b, so b is equal to 0. So y would equal negative 1x.